Welcome to Study Loop.
So for this one, if you want to know what the electron groups are, it is 2, 3, 4, 5, and 6. And that corresponds to linear. This one is trigonal planar. 4 is tetrahedral. 5 is trigonal bipyramidal, or TBP. And then 6 is octa. Right? So it wants us to draw. So for 2, you're gonna have this linear shape, but this linear shape is only going to have a x2, and it doesn't have an e. And its ideal angle is 180. For 3, you could have an angle going like this. Right? You can have it going like this because the lone pair is going to repel and bending these. And so this is going to be V-shaped and bent. Right. So 4, which is the tetrahedral, you can have, and then excuse me, for 3, its recommended angle would be close to 120, but could still be a little bit shorter than it. But it's going to try to get close to 120 in this bent shape. And its formula is A x2 E AX2 E1. All right, so for 4, which would be tetrahedral, you can also have a V-shaped and a bent formation for 4. Its V-shaped bent formation has this formula AX2. Hold on, let me redraw that. AX2 E2. And so looks like this. You'll want center atom, these bonds, and these lone pairs. And that's what the E2, 2 bonds and then 2 lone pairs. Its preferred angle is 109.5, but tries to get to as close as possible. 5 electron groups. 5 electron groups has multiple AX2E2 formulas, or AXMEN formulas. But the one you probably will see the most, or the one that's actually no, not the one you all might see the most, the one that's probably out of the ordinary would be the seesaw. And that one has a formula of X4, and the 4 is the 4 bonds. It's not E1 because you don't have to write the 1, but it's E1 because of this one lone pair. It prefers a bond angle of something close to 90, or a little bit less, but close to 90, and 120. Now, the 90 and 120 is different because it's looking for 90 going across its axis, and then 120 equatorial. But the best way to see these numbers is if you see it 3D. You might not be able to see where they're getting the 120 when it's on a flat surface. All right, and so for 6, I use the formula for AX4E2. So for this one, gonna have a center. It's gonna go this way. Gonna have something coming out in front. Actually, that's gonna go back. Gonna have something going this way in front. Yeah, something going out to the back. Then you're gonna have 2 lone pairs. All right, so for this one, you're gonna have 90 degrees as the ideal bond angle. Now for these, I know you can reference the table, or I guess the chart or summary on, if you go to 10.2, which is on page 413, to get other examples.